So today we're going to look at some right triangle trigonometry. So we're going to take that labeling triangles that we just looked at and apply that to the sine, cosine, and tangent functions. Trigonometry means triangle measurement. It's a Greek word that means triangle measurement. And the trig ratios are the ratios of the lengths of two sides of a right triangle. So these are our sine, our cosine, and our tangent. So we're going to use this acronym at the top, this SOHCAHTOA is how you pronounce this, SOHCAHTOA. This is the acronym that we're going to use to help us remember which lengths to use to write our ratio for sine, cosine, and tangent. So sine, we're going to look at this part, so the SOH. So for sine, we're going to use opposite over hypotenuse. For cosine, we're going to look at this, the A and the H. So we're going to use adjacent over the hypotenuse for our ratio. And for tangent, we're going to use O and A. So we're going to use the ratio of opposite divided by adjacent. So one more time, this is just an acronym that we're going to use so we know which sides of the triangle to use for the ratio. So example 1, we have triangle ABC with our right angle at angle B where the box is. And we want to find the sine of A, the cosine of A, and the tangent of A. So angle A is up here where at the top, so we're just going to mark that with our arc. And we're going to use our acronym, SOHCAHTOA. Okay, and then we'll go ahead and label our triangle. So across from the right angle is our hypotenuse. Across from our specified angle is our opposite side, which leaves the side of 6 over here as our adjacent side. So the first one, we want to find the sine of A. So for sine, we're going to use SOH. So sine, the ratio is the opposite over the hypotenuse. So the opposite side has a length of 8, and the hypotenuse has a length of 10. And we can actually reduce that. 2 goes into both of those, which reduces to 4 over 5. So our sine of A is 4/5. Our cosine, we're going to use A over H, so adjacent over hypotenuse. So the adjacent side has a length of 6, and our hypotenuse has a length of 10. We can reduce that as well. 2 goes into both of those, which reduces to 3 over 5. So our cosine of A is 3/5. And tangent, so TOA, so opposite over adjacent. So our opposite side has a length of 8, and our adjacent side has a length of 6. We can reduce that. 2 goes into both, so 4 over 3. So the tangent of A is 4/3. So example 2, we have sine of C, cosine of C, and tangent of C. So we'll go ahead and label our triangle. So across from the right angle is our hypotenuse side. And our specified angle in this triangle is angle C up here at the top. So across from that angle is our opposite side, which leaves the side that's labeled 15 as our adjacent side. So our acronym is SOHCAHTOA. And we're going to start with the sine of C. So that ratio is the opposite side over the hypotenuse. So opposite is 8, and the length of the hypotenuse is 17. That doesn't reduce, so our answer of sine of C is 8/17. Cosine is the ratio of the adjacent over the hypotenuse. So the adjacent side of angle C is 15 over the hypotenuse length is 17. That doesn't reduce, so the cosine of C is 15 over 17. And tangent would be opposite over adjacent. So the tangent of C, the opposite side is 8. The adjacent side has a length of 15. That doesn't reduce. So the tangent of C is 8/15. Okay, so triangle XYZ has lengths of 14, 48, and 50. And we want cosine of x. So our acronym, once again, is SOHCAHTOA. And this one we're looking for sine of x, so our specified angle is x. So we'll label our triangle. Across from the right angle is our hypotenuse. Across from the specified angle is the opposite side. And that leaves adjacent. So the sine of x, our ratio is opposite over hypotenuse. So the length of the opposite side is 48. Over the hypotenuse side is 50. We can reduce, 2 goes into both. So 24 over 25 would be our sine of x. The cosine of x, so cosine ratio is adjacent over hypotenuse. So the adjacent side has a length of 14. The hypotenuse has a length of 50. And 2 will go into both, which reduces to 7 over 25. So the cosine of x is 7 over 25. And tangent, that ratio is opposite over adjacent. So opposite side has a length of 48. Adjacent side has a length of 14. 2 goes into both. So 24 over 7. So tangent of x is 24 over 7. Okay, so last example, why don't you pause the video, try this one on your own, and then come back and check yourself. So notice we have the same triangle we started with, triangle ABC with lengths 6, 8, and 10, but this time we want to find the sine, cosine, and tangent of angle C. So angle C is our specified angle. So across from B, which is our right angle, is our hypotenuse. Across from C is the opposite side, which leaves the bottom this time as the adjacent side. So our acronym, SOHCAHTOA. And we want to start with sine of C. So sine ratio is opposite, which in this case is 6, over the hypotenuse length, which is 10. That will reduce 2 into both. So sine of C is 3/5. Cosine, we have adjacent over the hypotenuse. So the length of the adjacent side is 8, and the hypotenuse is 10. 2 goes into both, so 4/5 is our cosine of C. Our tangent ratio is opposite over adjacent, so opposite is 6. The adjacent length is 8. 2 into both again, so the tangent of C is 3/4.